Hmm. Ready? All right. Okay, I guess I can get started then.
And
Pam?
Mike, you can go ahead and share your screen. That would be terrific.
Okay.
So welcome, everybody. Thanks again for joining us. This is our third training for the semester for the automotive faculty at both our colleges and high schools in the region. We also have invited guests from our Southern California junior colleges. So welcome, everybody. Today, we have a very special speaker, Mike Hernandez, who is one of our instructors at Evergreen Valley College and oversees the car that cannot be named. That's a joke for Mike, who oversees the Tesla program. And Mike is going to share with us his insights. He's been working on these cars, more advanced electrical cars, for quite some time. So he has a very unique perspective on the types of skill sets that these particular types of cars require. And as we all move towards more and more electric vehicles on the road, it's very important for all of our faculty throughout the state to become more comfortable and more familiar with how to maintain and repair electric vehicles. So I'd like to introduce Mike. Mike, take it away. Thanks so much.
Okay. Well, thank you for joining. I hope you get something out of this a little bit. So being perfectly honest, everything in this presentation is my personal take on things. So please bear that in mind. Everybody has a bias, including me. So how this got started was I started teaching electric vehicles in 2005 in hybrid vehicles. I was certified by Society of Automotive Engineering. I was their pilot program for that new program they're setting forth, where they're doing the level 1, level 2, level 3 EV training from the Society of Automotive Engineering. Well, I was part of their initial pilot program about 8 years ago. And so ever since then, I've been keeping in touch with them and having literally monthly webinars to keep going on that with electric vehicles and the technologies for hybrids. So this particular thing excites me. I found it very interesting. We are a Tesla training program, and I may say that. So I have done many interviews with students that want to get into the Tesla program. So a lot of the things I'm talking about is based not only on the students that finished the Tesla program, but students that applied that weren't accepted into the program. And it covers a variety of students from many different schools, all the way from Santa Cruz to Sacramento. We've had students from Texas. We've had students from North Carolina. So we've had students from a bunch of different areas, mainly in California, but we have had people from out of state as well. So it's based on that. Next screen, please. Oops. Come on. Next. So good news. I want to start off with good news because I think I've known most of the people that are in this conference, or we've met from time to time. And I think everybody could be very proud of what they do in their programs. And that's been, I've noticed that not just by who's applied to Tesla, but the kind of student that applies to Tesla and what knowledge they had when we interviewed them. So to get into the Tesla program, you must take a written exam. You are interviewed. You're interviewed by me, by at least one or more Tesla instructors. And then based on the interview and based on how you did on the test, and also your college background, what your grades were, your experience, we would select the people that actually got into the program. So it's a pretty rigorous interview. So I got to know a lot of your former students that applied to the Tesla program. However, that being said, out of the 100 people that has applied, only about 30 actually got in the program, 12 at a time. So not everybody applies, but out of the 100 applications, about a third of them got into the program and 2/3 did not. Usually they did not get in the program because during the interview or during their tests, they showed they didn't really have the skills yet, the prerequisite skills, so that we had assurance they'd be successful. Not that they wouldn't pass, they might pass, but they might struggle a little bit more and might not be as successful. So anyways, it turns out that even in my school, and this may be the same with yours, if I have 30 students, 3 of them are probably going to be exceptional, with or without my help. And so there's always those top students that they're self-motivated, they learn quickly, they seem to have good hands-on skills, they work hard, they have a good work ethic, they strive for excellence, they don't want a C grade, they want an A grade, and they're determined to get there. That's the kind of person that's going to make it in this class. So I would like to be more than 10% of our students. And so some of the discussion I'll talk about today is how can we get more than 10% prepared? Because that's about what it looks like from the outside. Most of it has to do, 2 things that we noticed. Student that had work experience, had some actually hands-on experience in industry, even if it was just 6 months, seemed to be just much better than the student that just took classes. And that showed not only in their skills or hands-on ability, but also in their confidence. You have to be a real confident person. You have to be ready to do the work, feel like you know what you're doing, right? And if you do that and you have the confidence, you're not scared, you're not apprehensive, you really do go at it and you try to learn faster. So those are some of the things that we noticed in the students that did well. They had that confidence, they had that little excellent strive for excellence that made it possible for them to pass the class. The last thing I'll say about Tesla, and then I'll never mention their name again, only because this recording has to go to Tesla Corporation. Anything that has the word Tesla in it, Tesla has the rights to what was said. Because I had to sign an NDA, a non-disclosure agreement, that says I will not reveal any of their specific technical information. So I will tend not to do that. But I'll talk about the technologies that, if you know these technologies, which are common, it will prepare you to learn their specific technology, because sometimes there's not that much difference. So I hope you understand that. Anyways, that's kind of where we're at. Weaknesses. Now we'll get to the weaknesses. So believe it or not, even the ones sometimes we accepted into the program if I asked them a simple question about if resistance goes lower, what happens to current, they couldn't answer it. They couldn't answer that simple question. Or we'd show them a question, we'd say, here's two resistors in series. What's the total resistance of that circuit? So I got 12 ohms and I got 15 ohms. What's the total resistance of that series circuit? They couldn't answer it. We looked at their background, and yet they got an A in their automotive class for basic electronics. Now, many times it was over a year ago that they took the class. But our concern was, and this happened to my students too, so I'm not alone on this. They don't seem to retain things for long periods of time. They may have done very well in the class, but they didn't retain it. When they were in the program, we went over Ohm's law again. We went over some of these electrical rules and laws for series circuit, parallel circuits. And it did come back to them. They did remember it with a little bit of review. But the fact that we had to review it was a little striking. Now, that's across the nation. I've talked to other Tesla instructors in North Carolina, Texas, Florida, Washington. They report the same thing. The weakness is their students that go into their program don't seem to really retain all the electronic laws, rules, and basic operation for a long period of time. They need refresher. And so that's just something for us to think about, right? It happened to my students as well. So electrical circuit analysis. Electrical circuit analysis, we'll get into a little more detail on this. And this is where I seriously, in the bottom of my heart, want to thank Kurt and thank Mike for doing some of the training they've done. CAN diagnostics is something that we saw a tremendous weakness in. They understood what the CAN system was, but when you actually say, try to diagnose where the issue is, they struggled. They struggled a lot. And I'll talk about this a little bit more as we get into it. But CAN diagnostics was somewhat rare years ago. I think we can all admit that. It was meant mainly for most cars. It was the body electronics, right? Yeah, you had to connect the scanner up, but the body control was where you focused your CAN system on. Now it's everywhere. And if you go to an electric vehicle or even hybrid vehicles, that CAN system's used for everything. You can't have a self-driving vehicle without having CAN communication. I mean, you just can't have it, right? So CAN communication is just becoming so prevalent everywhere that you really have to know how to deal with it. And I think we can do a little bit more on that. ADAS, again, ADAS system, 15, 16, 17 years ago, nobody even knew what ADAS meant, right? I mean, there were some, right? Thank God they have German cars, right? Audi had ADAS, BMW, Mercedes, but it was still somewhat rare. Now ADAS is everywhere. I mean, there's hardly a car you can buy out there that doesn't have an ADAS option. So that was in hybrid cars earlier on. All electric hybrid cars had ADAS systems built in, not to the full extent they do now, but they were first. So that was something that was kind of nice to know. High voltage tools. I'll share with you some of the tools that I learned about that prior to taking electric vehicle training, I had no idea what these tools were used for. I mean, I did in aerospace. In aerospace, I used them all the time, but I never saw them used on cars, unless maybe it was an engineer that was working on a car, but not the technicians. So I'll talk about some of those tools. Glass replacement. I don't know about your school, but my school does not teach a student how to replace any glass. We don't replace windscreens, rear windows, anything like that. If you look at some of these electric cars, particularly one manufacturer, there's a lot of glass. I mean, there is a lot of glass, and they have to replace them on site, at people's houses, at companies. They take the glass with them, they install it. We didn't get to do any of that at our school. And there's a trick to it. I mean, it's like anything else. You've got to practice a little bit to do it right. Otherwise, you get water leaks or other things.
Mike,
HV.
There's a question in the chat box. And again,
Okay.
everybody, please put your questions in the chat box. So Kurt wants to know, should LAN have a greater part in our electrical instruction?
Sure. We'll get into that. Yes, Lynn has some. Now, let me be clear, and that's when I get into this, I'm just showing weaknesses. But when I get into this, this is where the balance is. When I teach electric vehicles, Honda does not sanction my certification. They do not. My training, and I've been fully certified in Honda hybrids, but I am not allowed by Honda Corporation to teach hybrids at my school. Let's be clear. It is suggested in many areas that although you can do some hybrid training, you can teach some of these technologies, it isn't until you've taken the manufacturer training where you will get actually certified. Because each manufacturer can be uniquely different. There are unique differences between one manufacturer and another in terms of the equipment they use, even the procedures they use to some extent. So they will not allow somebody to train hybrid and say, oh, you're a hybrid technician, go out there and start working. No, you must go to their individual training. So when we're talking about training internally, it's more generic in nature. You want to understand the technology, but to understand specifics for Toyota, Ford, Honda, wherever, stay away from that. I mean, you can show it, you can do it, but you are not a certifying agency, not at this point. Does that kind of make sense? Okay, so when we're talking about this, it's the generic technology. You can have specifics as much as you know it, but to be a certifying agency is going to be kind of tough for that company. Okay, so, but we have some hybrid tools that I want to just share with you some of the things that I looked at. Hybrid system operation. So hybrid system operation, ASE does not really require a lot of in-depth on hybrids. They just don't. It's not part of their requirement yet. So I'll share with you some of the things that we think are basic. I mean, just basic things that hopefully you cover so that they have a basic understanding. And I'll try to cover some of those things. R&R internal panels. Again, this may be specific to my school, but I noticed that a lot of other schools stay away from this a little bit too. And that is, I do not have students tear off panels. I don't have my students tear into panels within the car. If they do, they may do it once with being highly supervised. The reason is even the best of us, well, at least I do it, I can take a panel off one day, every clip is perfect. I can take a panel off tomorrow and I'll break a clip. So I'll break a clip here and there. Even if I'm careful, clips sometimes break, especially as the car is aged. We do not have every clip known to mankind. I do not have a stockpile of every manufacturer clip. Now, I want to be clear on this. I must use the recommended manufacturer clips. The reason being is hybrid electric vehicles are quiet and you can hear any problems. If you use aftermarket clips and they're not quite right, you might hear a squeaking noise. And that drives customers nuts. So hybrid electric vehicles, because they're all electric, they are so quiet that you hear every mistake made. And we'll get into that a little bit. That's another area that's covered mainly by the manufacturer, but we might want to think about doing a little bit of that so that people are aware about squeaks and rattles and things like that. But truthfully, up until last semester, we didn't even have that course. We now have it. We now have a harshness, vibration, and leak class where we talk about leaks and vibrations and things like that and how you might deal with it, techniques that you might use. The limiting factor is, man, you better have a lot of different clips. It's easy to break a panel. And if you have to buy panels, we can spend all of our automotive money on panels and clips. And we just don't have that much money. So we have to do it in such a way where we limit our liability in terms of cost. Okay, so R&R and panels. High voltage safety. I'm going to talk about high voltage safety. I trust every single one of you have already done it. You have a good safety program. I just want to share with you a few intricacies that came up with electric vehicles that you don't necessarily see in your typical hybrid, because electric vehicles have more current, more voltage, and we have to be a little bit more careful. So I'll share with you some of that. Work ethic. There's nothing I can do. I mean, some people say there's nothing I could do about my students' work ethic. That, you either born with a good ethic or you weren't, right? But there is nurturing. There is a way to nurture ethics and nurture professionalism. And I do want to talk about that a little bit, if you can bear with me. We need to up our professionalism. And I don't mean us as instructors need to be better. I think the instructors are great. But for many, many years, I've been teaching for about 16 years now. I have never yet, other than a couple classes that I do, I have never had part of their grade professionalism. Right? Are you a professional student? Do you have that professional ethic about yourself? Do you do things with highest quality? Where their grade depends on it. So we started putting that into effect a few years ago, and it helps. But I keep getting feedback that that's not part of their grade. Right? You can grade them on quizzes, you can grade them on labs, but how can you grade them on work ethic? Well, I say you can in a way. We try to get them to be as professional as we can get them to be, because it's that professional behavior that's going to either make them a good person, a good tech, or not so good tech, in my mind. And we look for that when you go to not only the Tesla program, but every manufacturer I talk to that interviews people, it's, hey, I can teach you technology. I can't teach you to be a good worker. All right. So somehow, if we can kind of put that in our program, I think we're better off. And then charging systems. So thank you, Kurt, for going over charging systems. That is really essential now. To know the different charging systems, what's good about them, what's bad about them. So anyways, that's kind of my laundry list, and I'll talk to each one. I can't go next. So next. Okay. So prerequisite. Besides those things, look, an electric vehicle is the same as any other vehicle. It has 4 tires. It has suspension. It has brakes, right? It always has a final drive of some sort, usually some kind of differential. It has air conditioning. It has those things to it. So one expects that any student going into an HV training program or any other program for manufacturer program, you know these things. You got them down, right? So, but notice there's nothing about engines. I don't have anything in there for for gasoline motors or diesel motors because they don't have them. HVs don't have them, so throw it out. A lot of the most of the electric vehicles, as far as I know, all the ones I've ever worked on, they don't have a transmission. Throw it out. I don't need to teach transmissions, right? I don't need to teach about emissions, right? We spend a lot of time talking about gas emissions. We don't have gas emissions. Throw that sucker out. So things that the cars don't use shouldn't be part of the buildup to a student going in that direction because it's not necessary. It's knowledge they'll never use. But these things they need. So that's something to think about. So when I created a pathway for electric vehicles, I did have alignment. I had brakes, suspension, tires and wheels, air conditioning, all these things. But I did not have anything having to do with engines, anything having to do with transmissions, or anything having to do with emissions. And so a lot of our courses were predicated for that for conventional vehicles, and that's not part of that pathway. It's not needed, period, end of story. So think about having a different pathway for a person going into electric vehicles versus a person going into conventional vehicles. Hybrid systems and subsystems. So the bare minimums, every single car has a DC to DC converter. I don't care what it is. It has to have it, right? So understanding what a DC to DC converter does and basically how it works, just in basics, right? You can go into as much detail as you want, but at least a person should have an understanding of what does the DC to DC converter does. And basically all it does is take a high voltage and make it a lower voltage because you have no alternator. You have no alternator, so how do I get the low voltages that I need to run everything else in the vehicle? DC to DC converter, right? Also, it could be used for, in some cases, boosting it up, taking a small voltage and making it a higher voltage, maybe to jumpstart the car or get things going, right? Ford does that on some of their on their older ones. A power inverter, DC to DC inverter. Now that can be many different names, and I'll share some of the names. It's a power inverter, that's generic, but it also can be the motor generator controller. Because where does the motor generator get its 4 3-phase signals? From the inverter. So the inverter actually controls that motor. So looking at it that way of saying, look, I got 3-phase AC going to my motor generator or my motor. Where does it come from? Comes from that guy right there. That is the frequency of it is going to determine what? How fast that motor rotates. The current coming out of this puppy is going to say how much torque is coming out of my motor. And that's the fundamental about electric motors. I don't need a transmission because I can control torque and I can control speed, RPM. And transmissions change torque. So I don't need a transmission because I can change the torque myself through what the inverter puts out. So it takes a DC signal and puts out some AC signal for motor control. But it also does the reverse. If I'm doing regenerative braking, I'm taking the motor now, and the motor's now a three-phase generator, and it has to convert it to DC to provide electrical current to other things and charge my high.
You're muted. You are muted.
Mike,
Muted.
how did that happen?
Oh, I'm sorry. I hit the wrong button.
Started talking Italian, Mike. Those hands started flying.
What did you hear anything I had to say on this slide?
No.
It cut off about a minute ago, if that.
Oh gosh. Well, thanks for telling me. Boy, that's a big boo-boo. Okay, let's go back. So inverters.
We
So
got the
inverter,
discussion on the inverter. We got that.
that's okay? That was
Yeah,
okay?
we got that.
All right, good. Then you didn't miss much except for my hands. So hybrid control system. So this is where that CAN system comes into place and understanding all that. In order for this car to operate, it's going to talk to many different things, many different things. Well, if I use a hybrid as an example, the hybrid has to know what the motor's doing. It has to know what the electric generator's doing. It has to know what the brake system's doing. It has to know what everything's doing in order to make a decision. And that's going to come with many computers communicating to each other. So this idea of looking at system orientation is becoming more and more important. I'm not looking at individual codes or individual subsystems now. I got to take into consideration everything that's involved in making this happen. And so looking at a overall arching view of how the system works is becoming much more necessary than it was in the past. And that's where CAN communication and stuff comes in, right? I need everything to be correct in order for this thing to do whatever it's being asked to do. And some students, we noticed that they didn't have that. They seem to be singularly focused and not have a broader view to where they're looking at all possible problems instead of just that one specific issue. I kind of hope that makes sense. So anyways, those are the kinds of things, right? Batteries. So battery technology in terms of, even ASE asked for that. You should know that there's such a thing called a high voltage battery and blah, blah, blah. I'm going to go into a little more detail about that. I think when we talk about high voltage batteries, the lithium ion batteries particularly, but it could be nickel metal hydride as well. When we test normal lead acid batteries, we can do load tests, we can do capacity tests, state of charge test. Not so easy on the high voltage battery, right? State of charge is a whole different animal. Capacity is a little different animal. How you charge it, how you monitor that high voltage battery is a little more complicated than just putting on a VAT 40 and saying, yeah, I got half CCA and 9.6 volts, right? I measured 12.6 volts, so that means it's 100% charged. It's a little different than that, right? They work differently. So we should understand some of the subtle differences. Even the AGM battery, because a lot of cars now are using AGM style batteries, we need to introduce our students to AGM. What is an AGM battery? How do you test it? How do you charge it? And you have to be a little more careful with it, right? You have to be a little more careful with that AGM battery, right? I can't load it the same way I load a lead acid battery because it will internally destroy itself. When I charge it, I have to be a little careful on what my charge rate is and how much amperage I'm providing it. So I have to be a little more careful with that battery, or I might do more damage than I do good charging it up. So just to understand what that auxiliary battery functions like. Can you guys still hear me?
Yes.
Okay,
Yes,
good.
no problem.
Tell me if you lose me again. So anyways, those are some basics. And it doesn't matter whether it's a hybrid car or an all-electric car, it's going to have those things, right? Now, there are other technologies, granted, but having a fundamental understanding of those things, I think, is kind of important. For instance, I'd ask a student wanted to get into my EV training, my Tesla training, and I said, what's regenerative braking? Oh, wow. It's using kinetic energy to charge the battery. Oh, okay. How does it do that? It uses kinetic energy to charge my battery. And I said, okay, that's cool. They knew the words, but they had no idea how it was done. We should know how it's done, right? What is it really? Well, what it is the motor generator is a generator, right? So I'm no longer a motor, I'm a generator, and I generate AC, and I got to convert that AC to DC. But even with that, how does that motor generator change? How does it go from a motor to a generator? So that kind of concept I'll talk about a little bit, and they should at least understand the concept. Fair enough? Okay, next, safety. For years, I had taught people how to test gloves. And I said, do the roll test. Take a glove and roll it up, get a little puff ball in there and say, whoa, it's safe. And every manufacturer I've ever gone to, Honda included, says, do the roll test. Just take the glove, roll it up, and get a little bit of air stuck in it and make it good. It was adamant, you must do this. You must inflate it, and you must get an inflator. So I bought 2 or 3. And that inflator, when you inflate it, you are shoving quite a bit of air in it, and you leave it there for a considerable amount of time. It says less than 60 seconds or greater than 60 seconds. I've actually trained my guys 5 minutes. You watch that sucker for 5 minutes. If it leaks at all in 5 minutes, you got a problem, right? But I want to get enough air pressure in there to where I'm really stretching out all the rubber to make sure that there is no air escaping. But this roll test is not adequate. The roll test at best will basically test the fingers, but they don't do the palm, and they certainly don't do the part that's on your arm. So think about inflators. They're unbelievably expensive for what they do. They're like $300, but they're still very necessary. Mark the date, because gloves are good for 6 months once you remove it from the package. They're good for only 12 months, never been used. I got them, they're in my package, they're sealed. They're supposed to only be good and need to be retested every 12 months, never used. The minute I use it, I can only use it for no longer than 6 months or whatever sooner. And that's the key, whatever sooner. So if I don't unwrap it for 10 months, I can't use it for 6 months more. I can only use it for 2 months more because the 12 months is expired. So on these electric vehicles, they kind of stress that a little bit. They stress that because they said, look, the voltage and the currents we're dealing with, if that glove is not good, you could get harmed. So they really do that. The second thing is, are we giving our students the correct size gloves? It really is important that I measure my students' hands and get them the right size fitting glove. And it's really, it has a little bit to do about safety. Yes, it is safer, but more dexterity. Look, if I got rubber gloves on and then I got leather gloves on top of that, it's like picking up a 10 millimeter Volt with boxing gloves on. Not easy, right? I'm trying to handle these things. I'm trying to get small parts, small bolts, small things. I'm still using small bolts stuff, but I got boxing gloves on. So the trimmer I can get it, the better I can fit you, the more dexterity you have and the more capable you're going to be working on stuff. So it's kind of important.
Mike, there's a question.
Sure.
Are you sending out the gloves to recert or just replacing them?
I do recert them. We'll get into inspection next. I'll do an inspection. If it looks like it's in good shape, I'll send it out for retest. But if it looks at all used, I throw it away and I get another one.
Thank you.
And I'll be honest with you. I'm a little more lax when I'm dealing with my hybrid cars, especially my older ones that only have like 144 volts on it. But when I get into EVs, yeah, I'm replacing them puppies because the voltage and the current is so much higher that the most minor defect could bother you.
And the follow on that question is, can you share the information on the company for the research?
I send it to the same manufacturer that I buy the gloves from. I buy my gloves from, gosh, now the name escapes me. Let me answer that. I'll look it up and then get you.
Okay, I'll remind you later.
I've even sent it to Snap-on. Snap-on will recertify as well. They will send it to a recertifying agency. There's only a few in the area. Usually I have to ship it a fairly long distance. I apologize. I will get that to you, Pam.
Okay, no problem.
The other is the leather protectors. So the leather protectors, if I have a size 8 glove, I want a size 8 leather protector. Whatever size glove I wear, I want the same size leather protector. So I don't want gloves that fit me nice and snug and then have these really loose leather protectors on top of it. I want everything to be as snug as possible. So same size glove, same size leather protector. So I will honestly say to you, when I did my hybrid classes, I was a little lax on some of this. Hey, look, as long as you're wearing a glove, you're good, right? But when I started doing the EV stuff and I started being trained on EV and actually work on it myself, I realized having the right size fitting glove was kind of imperative. Lastly, visual inspection. So most of the manufacturers, when they do visual inspection, they just say, oh, okay, look for any marks, look and see if there's any pinholes or things like that. There's more to it than that, right? I really want to kind of stretch them. I don't want to just look at the glove and say, well, it looks good. I want to kind of pull on it, tug on it just a little bit and see if I see any cracks or minor cuts, snags. Does it look like any chemical got on it? And by the way, oil is a chemical because oil has all kinds of, as you know, oil has all kinds of agents in it, cleaning agents and all kinds of additives in those oils. Those additives may affect the surface of the rubber. So these rubbers are not necessarily, or I get, God forbid, gasoline on it. So if I spill anything on these gloves, it could contaminate them a bit. UV. Well, UV, I don't have a UV checker. One of my manufacturers actually has a UV checker. I don't. But what I do is when I wear these gloves, when I put the gloves away, I want to make sure I minimize the exposure to direct sunlight. So all the training, all the stuff we do on the cars is inside the shop. So we don't have direct sunlight on the gloves. And I got to try to watch that and make sure that that's in good shape. Get rid of this thing. Put it up here again.
Mike, there's another follow-on question on the recert of the gloves. The question was, what is the cost? And
it's expensive, $45.
$45 to reinsert the gloves. 'Cause replacement
Yeah.
might be a little.
Yeah,
something-
I used to buy both the rubber gloves and the leather protectors together for about $50. Now they're over 100.
Yeah,
Some of that, and especially now, I will say that now they're even more, because anything made out of rubber, because of COVID-19, all these gloves have gone up, right? Even my neoprene gloves, my gosh, the price on the neoprene gloves have almost doubled. So they are a bit expensive. If you take care of them, I've had gloves for over 5 years
wow.
where I recertify. So it is an upfront expense, but if you're really careful with them and you teach the people how to use them properly, and they wear those rubber protectors whenever they're touching something, the rubber gloves don't get damaged. The leather protectors could get a little scratch or get a little stuff, but that's what it's meant to do. Those leather things are meant to be beat up. The rubber is meant to be safe. So the rubber lasts quite a long time. They can be reused multiple times.
Ed
But
mentions that the Mazda dealership that he worked with had a company that just automatically sent out new gloves every 6 months.
sure, and the company, my Tesla program, they get new gloves every time, every class, period. End of story. They have stockpiles of these things at Tesla. Literally a room of thousands of gloves, and so they'll change gloves at any whim. I'm just saying, in practicality, being that we're a school and we have limited budget,
Right.
and we're not going to train on electric vehicles. We're training on hybrid vehicles, which have a lot less voltage. And how often am I really going to work on the electrical side, the high voltage side? I'm going to have limited exposure to the high voltage side, right? We can do a lot of diagnostics without touching the high voltage. But when they do, gloves. But on the Tesla training, I don't mind mentioning it. I hope they don't yell at me. On the Tesla training, you are dealing with that daily. So it's imperative that they change their gloves much more often, that they take care of their gloves much more often, because it's a daily activity, not an every once in a while activity. Does that answer your question?
Yes, thank you.
Okay, so avoid folding it. So you're not supposed to take the rubber and fold it and put it in the package where it's just kind of crumpled up and put in a bag. You want to make sure that that glove is not folded. And it's actually not even flat. You're supposed to hang it upside down to where it doesn't have any downward weight on it, to where it can cause it to be deformed. These are things that Mike Hernandez did not know about. I did not know that you had to take so much care with these gloves. But that's true. The storage and things like that, again, you don't fold it, you don't compress it, you don't have sunlight. The storage temperature, store it in a place that doesn't get hotter than 95 degrees. You may wash it with warm water, but just warm water, about 85 degrees. You may use a mild detergent, but then you got to make sure it's really dry. You do not want to have a moist glove on and touch electronics, right? So you want to make sure they're nicely air dried, and you test for that. These are just things to consider. I want to point this out. There are standards. This ASTM F696, that's the standard for leather protectors. ASTM F696. So if you want a standard to go by, that's the standard for the leather protectors. There's also a standard for the rubber gloves themselves. ASTM D120. So I want to mention that to you only because automotive did not have a separate standard for gloves. They used the standard that was used for like PG&E that works on high voltage lines, works on really high voltage. These standards were created for that, and then they kind of adapted it for automotive. So these standards will go into excruciating detail about what the gloves, what the gloves made out of, things like that. So if you want to refer to a standard, those standards are not standards. Those are the standards that industry is supposed to adhere to. Okay. New tools. Oh, I'll try to go faster because I'm taking too much time for you guys. So some of the new tools that I came across was a low resistance meter. Now this low resistance meter, I happen to use the Hioki. The Hioki meter was one. There's many different meters. It's not just Hioki, but it's a 4-wire resistance meter. It uses 4 wires, not 2, because it has to compensate for lead resistance and contact. The actual contacts right here that go on to what you measure, those are very special metals, and they have to make a very good, they're very excellent conductors. It measures anywhere from about 3 milliohms up to 3 megohms. 3 milliohms, but it has a resolution of 0.1 microohm, 0.1 microohm. So they measure very, very low resistances. Let me explain why that's important. So 2 things. 1, if I'm looking at the coils of my stator or my, if it's an inductive motor, I'm looking at those stator windings, or I'm looking at my rotor windings. In some manufacturers, they actually measure the resistance of each one of the windings and see if they're to a spec. If they don't have a spec, they at least say, look, I looked at this winding and it measured 3 mils. I measured this one and it measured 7. I measured this one and it was 3. They do at least do a comparison measurement. Does it look like my coils are the same value or near same value? So if they don't have a spec, you're at least looking at, are they the same resistances evenly around the coils? The second thing, and this is the one that shocked me, is when you're dealing with high voltage cars, whenever you connect any of those high voltage lines, the orange cables, and you bolt them down, before you bolt it, you must use something like isopropyl alcohol and clean the surfaces. Make sure those surfaces are clean of oil, grease, any contamination. Bolt it down to torque spec, and then measure from the top of the bolt to what it's fastened to, and make sure that it has very low resistance. So that's a double check of making sure that I made really good contact with any of those bolts. And we have seen instances where we torqued it to the right torque, but when we measured the resistance, it was still a little high. So we unbolted it, cleaned it a little bit better, made sure the washers and everything were didn't have any grooves or any gouges in it, refastened it, and okay, the resistance is now low. It was absolutely imperative, because the higher the current, the more voltage drop you're going to get. So when you're dealing with these really high currents, my gosh, those connectors have got to be, they got to be good. They got to be really good. So, so not only to measure coils and windings, but also to measure to make sure that you made good, solid contact on any of those high voltage connections. Insulation tester. This is pretty common. I had this already, but insulation testers are important. This insulation tester, I'm not even that, oh yeah, I have the right picture. So it comes in different ranges. I want to have it to where it can do many different voltage ranges, 50, 100, 250, 500, and 1,000 volts. The reason being, if I'm looking at the orange cable, I want to shoot 1,000 volts down that cable. I don't want to measure resistance using my 9-volt battery inside a normal voltmeter. I want to shoot 1,000 volt spike down there and see if there's any leakage using 1,000 volts. But when I'm doing isolation on my electrical components, inverter, converter, things like that, I can't go at 1,000 volts. I got to go 200, 100, maybe even 50. I want to go more than my typical 9 volts, but I got to use lower ranges. So when I measure the resistance of my orange cable, on the one I have at school that I use, it actually goes up to 22 gigohms. So if it doesn't say 22 gigohms, it failed. I got to have 22 gigohms or more, which basically means it's overloaded. It's maxed and at 1,000 volts. So insulation testers, absolutely imperative. My understanding is that if a car gets in an accident, the manufacturer is required to test an isolation test every orange cable in that car. Because if the car was crumpled, if the car was damaged in any way, you don't know if any of those cables were pinched or had some kind of puncture. So obligated to test every orange cable and make sure that, man, those orange cables are in good shape. So I do that in my class as well. So it's kind of nice to know. It is something that I believe every manufacturer does, be it hybrid or electric vehicle. The other one is picoscope. So a lot of the signals we're looking at, and I think Michael might have mentioned that when he looked at his CAN signals. Yeah, you can do some diagnostics on CAN. You can do some self-checks on CAN. But sometimes you just want to see what does the signal look like? Is it starting to round over? Does it have any deterioration on it? Does it look like it's a nice square wave, or is it distorted a little bit? You can't really find out whether that signal's good or not unless you look at it. Furthermore, a lot of the other signals we test for charging system, when we're in the charging system, we're going to be looking at I think I spelled that wrong. Yeah, it's called pilot, Michael. Dummy. I did that wrong. Yeah, I said POLIT. It's the pilot and proximity circuit. So we're going to be looking at those signals. We're going to be looking at sine wave signals. We're going to look at waveforms every once in a while on some of the technology. The only way to look at those waveforms is to have a good scope of some sort. Industry in general, from the people I talked with and the ones that I worked with, they kind of like this picoscope or something like it, because not only can you capture the signal, but you can expand it and really get down to the nitty gritty of what that signal looks like. It's just a nice tool to have. You don't necessarily need 4 channels. 2 channels is more than adequate for most instances. I've had some instructors in my school where I bought a couple 2-channel ones, and they said, no, buy a 4-channel. I need a 4, I need a 6, I need a 10. Well, okay. If you want to buy the 4-channel, but it's twice as much money. I mean, literally twice as much money. So I limit it to 4, to 2 channels. The 4 channels a little pricey. But
Yeah, pricey. We're having some commentary about the price of the Hioki. It's about $1,200 on Amazon.
yeah, so again, let's be clear. I said Hioki as an example because I must use that one for the training that my students go into. Okay, but there are many low resistance meters, many different manufacturers. So it's the low resistance meters. It's still a four wire resistance, but I just want you to realize you are going to measure fairly low resistances, right? A lot less than 1 ohm, a lot less than 1 ohm. So the only way you can measure a lot less than 1 ohm accurately is to have a meter that can do that. And so
Mike wanted
that's
to know if there were some general specs on the resistance with the connections. General
well,
specifications.
I can't tell you, but this meter has a range, right? It has a range. Yes.
Yes.
Okay. And that's all I can say.
Okay.
But I'm not so picky about going down to a certain value, but if the students have familiarity with low resistance meters, doing it in a 4-wire hookup, it's knowing how to do that that's important. And by the way, this helps a lot even if you're doing fuel injector coils. If you're looking at ignition coils, if you can measure the ignition coils more accurately, if you can measure fuel injector coils more accurately, relays have a coil. Sometimes by measuring the relay coil resistance is a way to determine whether that relay is good or bad. So having a low resistance meter has multiple purposes beyond just checking whether or not you made good contact. I hope that helps.
Yes.
So,
Thank you.
a lot of schools that I went to had nothing to do with hybrids, nothing to do with EV. They had low resistance meters because anything that has a coil in it, solenoids, relays, to measure those coils more accurately gave you a better measurement. I hope that is an okay suggestion.
Yes.
And then picoscopes. It doesn't have to be a picoscope. It just the school the program that I have happens to use this scope. So I bought a few mainly because if I can train my students how to use this thing, then when they have to use it somewhere else, they have some familiarity with it, right? And they kind of understand how it works. Now, there are other scopes that hook up to a laptop computer. And if that scope hooks to a laptop computer and you can use your computer to manipulate the measured value, good. It's just understanding that the more familiar you are with that kind of technology and how to use it, good on you. Charge systems, I'm not going to go into this because Kurt did such a great job on charge systems that I don't need to talk about charge systems. But it is imperative that you got an understanding of what are the main standard charge systems that are used today. And that doesn't have to do with electric vehicles. It has to do with any of these vehicles we plug in. Understand what they are and try to understand the limitations, right? Not all charge systems work on all cars, right? Some cars are pretty picky about what they plug into. Others are not, are a little more robust. So understanding the different kinds of charge systems that are out there and what their limitations are, how long it takes to charge something, when you use this one versus another one, it's just nice to know. You don't have to spend weeks on it. A simple single lecture to just introduce students that no, there's not one kind of charge system in my world. There's many different kinds of charge systems and kind of what they are. Auxiliary battery, we already talked about that. AGM batteries, how do you charge it? How do you test it? And any concerns that you might have about that battery. One major concern that I hope everybody realizes, AGM batteries, I'll talk about, Toyota. The Toyota Camry, there was a write-up not too long ago that says, yeah, my Camry is a great car when it starts. And why it didn't start was the 12-volt battery went dead. And it went dead rather easily because it's small. It's a dinky little battery. It doesn't have a lot of charge. It doesn't have a lot of capacity in it. So these little batteries don't really do much. They close relays, they close contactors, and then when the high voltage goes in there, the high voltage then goes through the DC to D converter, provides all the power of the car. That 12-volt battery is not used for much of anything. Because it's not used for much, if you overuse it, boy, it goes dead quick. And secondly, fine print, very fine print. Some of the vehicles will say to you, you must drive your car at least once a week. Well, the reason you're driving your car once a week is not so my wheels are good. The reason you drive your car once a week is that charges that 12-volt battery. Because if you let that car sit for more than a few weeks, typically 2 to 4 weeks, you may come back and that auxiliary battery is dead. So people need to understand that. They need to understand these 12-volt batteries aren't as robust as the lead acid batteries used in conventional cars. They go dead pretty easily. State of charge, high voltage batteries. So state of charge, just to introduce them to these subjects, right? When you do high voltage battery state of charge is a little more complicated on high voltage batteries. And that is, I can't measure a voltage and determine what the state of charge is. It's more complicated than that. The high voltage battery maintains a level charge for a very long time. My explanation is this. Have you ever used an electric drill? If you used an electric drill to screw in bolts or to screw in screws, usually it works about the same from the first screw to the 100th screw. But then when you get to the 101st screw, it dies. It's gone, right? But for the first 100 screws, my gosh, it got all of them about the same amount of torque, and I was able to screw all 100 screws well, and then died. So it doesn't slowly deteriorate. It maintains it, and then it drops off. So state of charge is not a matter of, does my voltage decline? It's more of how much current did I use? And the car constantly measures how much current came out of the battery, how much current went into the battery, and it kind of keeps track of how long that battery was used, delta state of charge. It kind of keeps track of that. It uses internal resistance of the battery sometimes as part of its calculation. But the bottom line, the SOC is a calculated value. And it takes multiple things to get an accurate SOC. And the car has all that built into its software, but it's a little more complicated. The key on batteries.
I'm going to interrupt for just a moment. There's a couple of comments in the chat.
Go ahead.
So Ed has basically identified where you can look at the pneumatic glove tester by Salisbury from Mitchell
Yes.
Instrument Company. And Kurt
Yes.
comments that home wiring and capacity are the causes for more EV charging problems than the cars. That's the home wiring capacity of the home.
Yeah.
And then John is mentioning that for the 12-volt battery, depending on how the vehicle is equipped, there can be a larger AGM battery available. They upgraded to the larger size for a fleet of Priuses with a different bracket available from the dealership. And Ed has in the chat a good site for checking glove recertification replacement costs.
Sure.
I think
I don't disagree with any, all that is correct. Thank you for adding all that value to it. But let me explain this. One would think that the high voltage battery would, as soon as the keys turned on, the high voltage battery would automatically go through the DC to DC converter and trickle charge the auxiliary battery. And that's not always true. Sometimes you actually have to have the car running to do it. So one of the reasons these these auxiliary batteries go dead is the high voltage battery does not always kind of trickle charge it. It doesn't always do it. Now, when I do the Leaf, the Nissan Leaf does not have a auxiliary battery problem, because the Leaf will charge that 12-volt battery, whether the car's running, whether the key's in it or not. It keeps that alternative battery at a certain state of charge. A lot of these other vehicles don't do that. So we just have to be a little careful, that's all. But yes, you can boost up the battery. You can put bigger ones in. However, buying bigger batteries, sometimes the battery compartment that it fits in will only take a certain size battery. I can't force a bigger battery in there, physical size. So, so it's just something to think about, something to discuss. But yes, in some cases you can, and in some cases, no, you can't. You can't physically get it into the spot, into the place. But anyways, we can discuss that further. High voltage batteries. The key on high voltage batteries: balance, 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 balance. Each one of the cell modules should equal the cell module of the one next to it. And so when you're doing these high voltage batteries, we need to make sure our students understand that, you know, the charge balance and the voltage balancing of those battery cells, absolutely imperative. Absolutely imperative that they be well balanced. So most of the technology that goes into these vehicles, when the car's controlling the charge of the high voltage battery, is making sure that it's checking and double checking and triple checking that the battery stack is well balanced. And so that's just a concept that I hope you can at least let your students understand. The configuration of the batteries could be different. So some battery stacks are series connected, 100% series. Some battery stacks are series and parallel. So understanding what series and parallel connections, what's the difference between serial and parallel connections, kind of nice to know. It's not a difficult thing, but it's to know that the way the high voltage batteries are actually constructed, they could be constructed quite differently. And safety procedures. The biggest safety procedure that I want us all to understand is, and it's kind of elusive the way some of the manufacturers talk about it. They say if you remove the service plug, you're safe. Well, that's nonsense. You remove the service plug, the only thing you've done on most of these high voltage batteries is you cut the battery in half. But when I'm a technician and I'm testing that high voltage battery, well, I can get killed by half the voltage. Half that voltage is there. So depending upon where I am on that battery, just because that service plug is out doesn't mean I'm safe. It means that at the output of the battery, the output of the high voltage battery might not have voltage on it, or current in this case. It won't have voltage or current. But the battery itself, when you're testing it, when you take that cover off that high voltage battery and the service plug is removed, you can die by just testing too much of that battery. The other one that I show my students, and I make sure they understand that, is when I take my high voltage battery out, a lot of times the contactors are near the high voltage battery, are connected sometimes to the high voltage battery frame. I prove to them that if I kind of poke around with the leads, I can get half the battery voltage across those contactors. The service plug is out. And if I'm playing around those contactors, oh, buddy, I'll be half dead, right? It's enough to kill me. So it is absolutely imperative that you wear those gloves when you're dealing with this stuff. Because I had one person tell me, oh yeah, I work for a certain automotive company and I wore neoprene gloves and I completely removed the high voltage battery and put in another one and I'm still alive. I said, good, you're lucky. Because just because that plug's removed doesn't mean that it's safe around that high voltage battery or its contactors. That there's still voltage around there and you got to be really careful about it. So I just want to make sure that people understand that. So I physically show them that voltage exists, that it's still there. And so just because you think the car's safe doesn't mean that your gloves come off. You measure everything and make, you just don't work around high voltage areas without gloves, period. You just don't do it. It's there even if you didn't find it. First responder guides. I love first responder guides. They're free of charge. You can go online and just say, 2012 Toyota Prius, first responder guide, and boom, it'll come up. By federal law, they must be public record. They must be available to the public. There's a lot of good information on those first responder guides. So, and it goes into what kind of battery, the basic configuration of the car. It gives you a lot of information about how that car is constructed. And you can pull that up on any car. Sometimes in my class, I just pull up first responder guides and I said, let's go over this so we at least understand what's unique about this vehicle. And it gives a lot of good pertinent information, and it's free. It's 100% free. Contactors. For those that have taught Toyota or familiar with Toyota, Toyota vehicles typically have 3 contactors, and so the way they close the contactors is a very specific method, so that they have a resistor in there that limits the current flow, so that before I give high voltage to everything, I want to make sure that when that high voltage comes out of my battery, that it's not going to some short circuit down the road. So they close these contactors in a very specific way, right? That's pretty common for the full electric vehicles that I've worked with. That's a very common method. So if you get a chance and you just say, look, the way the car closes its contactors, the way high voltage goes from the battery, the high voltage battery, to the DC converter or to the inverter, the way those contactors close, they just don't close all at once. They close in a certain sequence. It's just kind of nice to know that there's a sequence to it, and that They have limiting resistors in there sometimes. They limit the current. They just don't give full current out. I hope that makes sense. So it's just one of those things that's very common to a lot of hybrids and EV systems, just so the students kind of understand that. Well, we're talking about contactors. The majority of the contactors, I won't say all because I don't know what all is, but the contactors I've am familiar with, what closes the contactor is the 12 volts. That's where that 12-volt battery comes into place. So by turning the car key off or taking the fob and putting the fob at 10 feet, minimum 10 feet away from the car, it assures that it's one way of safety of saying my 12 volts is not going to my contactors. So my high voltage should not go beyond my high voltage power supply. That my high voltage battery is where it stops and it doesn't go beyond my high voltage battery. That's why one of the safety mechanisms is just make sure that car's turned off. If it's turned off, the contactors should have opened because the 12 volts is not there. And the car is at least should not have high voltage from the battery anywhere else. But you want to measure it before you still want to wear gloves and you want to measure it and ensure yourself. But that's the reason for the contactors. So did you, if you guys attended the Tesla training, Pam asked Tesla to come on and do some Tesla training. And we saw that explosion in that shop in China, and it had a big explosion. That big explosion was really the contactors. The contactors got shorted out. So the voltage going to these contactors are pretty, well, they're high. So when we're training our technicians, we want to pay really good attention to making sure those contactors, and that if you're replacing them or removing them or anything like that, boy, you want to make sure it's done properly, because if it's not, and they happen to short out in some way, it can cause a fairly high spark. Anyways, system operations, CAN diagnostics. Again, going back to Michael's presentation when he talked about CAN system, is we need to really emphasize this a little bit, because everything in that car is, different sensors, different computers talking to other computers before a decision is made. And understanding the system orientation is absolutely imperative when you're dealing with these cars now. You just got to know that I got to have the system understanding, and then I can get to the detailed understanding of the individual components or individual subsystems. But I got to understand that everything nothing works standalone anymore. I mean, it's kind of like almost everything needs something else to be there in order for the system to work. And that's all CAN communication. And just another example of it, even when we're talking about hybrid controllers, when I'm talking about my electric motor, my gosh, I got to know a lot of things to know what RPM to give it, to know what current to give it, to know, what stator coil I'm giving voltage to, and what the frequency is. There's just a lot of information. So again, the more they get kind of a system overview, the better off we are. This notion of a rotating magnet, a rotating magnetic field, when we're dealing with electric motors, just realizing that 120-degree phase shift of the U, V, and W high voltage, that's what causes the magnetic field to kind of rotate around. And if the magnetic field is moving, then the rotor's moving. And just the concept of how that kind of works. We don't have to go into excruciating detail, but just the concept that I have to have not only a magnetic field, but it has to be a moving magnetic field in order to make the motor rotate. And induction. I know every one of you have talked about induction. If at a minimum, you've talked about induction when it has to do with, how does a ignition coil work, right? So we've talked about induction in terms of ignition coils, but we want to go into a little more detail about induction and how induction works, what really happens and why in this notion of the magnetic field. We talked about it with the ignition coils. We talked about it when we talked about alternators. So it's just to reinforce that mutual induction and stuff is really necessary when it comes to how these motors operate. I can't tell you how many people we've talked to where I said, how does magnetic field used with motors? And we got a lot of blank stares from a lot of candidates. And so it's kind of nice to get them to know that. If we talk about slip, it's maybe not as necessary, but when we talk about slip, and slip is basically what's the speed of the magnetic field relative to the stator and rotor. Is the stator moving faster than the rotor? Is the rotor moving faster than the stator? This positive and negative slip is basically telling you, is that motor a generator or is that motor a motor, right? Is it an electric motor or is it moving the wheels, or are the wheels moving the motor generator and now it's a generator and I'm trying to slow it down. I'm trying to prevent the rotor from moving, and that's regenerative braking, right? So the reason it slows down the car is I can set this thing into a slip where, yeah, the wheels are turning the motor generator, but I can make it more difficult for the wheels to turn the generator, thus slow the car down. And so just understanding that, how I magnetize these outside coils relative to the inside coils, I can either make that motor be easy to turn or make it a little more difficult to turn so that I can actually brake the car. Brake being slow the car down. And so just the notion of what slip is, kind of nice. And I just put a couple things in there. Just simple concept. Permanent magnet motor, what's the difference between permanent magnet and an induction motor? Just going over the basic concepts of how this thing is different and how it might, how it's configured differently, right? Where are these permanent magnets? Why are some of them flat? Why are some of them angled? You can get into that detail, but just the notion that permanent magnet motors are not the same as induction motors, and basically their operation is a little different. So I'm going to end there. My summary is this, and please comment whether I'm out on la la land or not. My general summary is this: you may not need to add new courses. That may not be necessary, but if I can take new technologies and incorporate them in my existing courses, but the only way I'm going to be able to do that and use the same amount of faculty and use the same amount of room is I have to consider eliminating some old technologies. Our rule of thumb at our college, whenever we discuss this, whenever we update our curriculum, we discuss this. Michael, how am I going to add this new stuff if I don't have enough hours to teach the old stuff, right? Anything older than 10 years, anything older than 10 years is a candidate for removal. Doesn't mean you have to remove it. Doesn't mean you have to, but you should consider it. So if a technology is older than 10 years and there's newer technology that's replaced it, I may want to have my class focus more on the newer technologies and less on the older. If you don't eliminate it completely, at least spend less time on it, right? I don't want to talk 3 hours on carburetors. I threw 800 carburetors away. 800 carburetors were thrown away about 4 years ago because we don't talk about carburetors too much. We do mention them. We say, yep, there is such an animal called a carburetor, and we might spend a little bit of time talking about what a carburetor is. But I would spend more time on, hey, how does fuel injection work? And more importantly, how does direct fuel injection work, right? So port injection, direct injection, and less about throttle body injection, less about carburetors. If I don't remove some of that stuff, I don't have time to introduce my new stuff. And that goes across the board. So we try to make it a policy in the school when we update our curriculum, put all the instructors in one room and say, you know, I have to satisfy ASE, so I will do what ASE tells me. But at the same time, how much time do I really want to spend on this versus spending time on the new stuff that the technicians, when they go work on cars, the majority of the cars they're going to work on are going to be somewhat newer technology. That doesn't mean the old technology doesn't exist, but kind of emphasize the new. Consider techniques to improve retention. One of the things we noticed, we being me, the Tesla instructor that did the interviews, was we were surprised at how that students that did very well in college, did very, very well in programs, 6 months, a year later, gosh, they forgot a lot. I mean, they forgot a lot. That's worthy of discussion, right? It's just something to discuss with the faculty and say, you know, when I teach my class, do I have a combination of lecture and reading and hands-on? If I have more than one method of instruction and they get multiple ways of practicing and doing things, the more practice they get, the more they get to do something, the longer they're probably going to retain it. But we have noticed that there is a retention problem. That, boy, if they don't use it or they haven't used it enough, boy, they easily forget it. And it's hard to re-educate everybody if you want to move them forward. Modernizing equipment, that's always the case. As new technology comes in, new techniques come in, how much time do we want to spend teaching the old methods versus the newer methods? I personally believe that I emphasize more the modern way of doing things and less the old style way of doing things, only because there's only so much time in a class day. And then professionalism. Really consider when I'm evaluating my students, even for their grade, that if a student is not being professional, somehow we got to be able to tell that student, you need to step it up, right? You need to be more quality oriented, or you need to invest more time in this. And if you don't have this professional attitude, that, yeah, you can get through the class, you can get through the program, but you may be limited as to how.
You're muted, Mike.
Mike, you're muted.
Okay, so anyways, it's just that professionalism. I just don't think I don't know, maybe it's just my school, maybe it's just me. Um, I don't think we spend enough time of saying, I just want you to be good. I want you to be, I don't want you to be good. I want you to be as great as possible and really install this professional attitude. Companies want the best professional person they can get. Anyways, I'm done. And current slide now is any questions or comments? And I'll stop my
Thank
share.
you. There was a few comments that I'll get to real quick, but I'd also like folks to think about asking any questions you like at this point. So I'll open it up, because one of the most important takeaways that I asked Mike to think about, given all of the new technologies that are coming our way, what can we really cut? And that's something that each of you will have to think about for your own programs, because we are already at the limit. Our programs are pretty packed, and it's essential to really think about. We've had this discussion, Kurt's brought it up many times, about the new fundamentals, the new automotive basics, that we have to prune some of those areas that are not what we're really focused on anymore. And I think he made a very good, list of examples for us to think about, reducing your time on carburetors and focusing more on the new technologies. So for those of you attending, do you have some thoughts about what you can cut from your classes and the new things that you're going to add? And everyone can unmute at this point if you'd like to participate. That'd be great. Any thoughts?
You guys are terrible.
Oh,
No,
good.
I think Mike hit it. It's, the funny thing is, as fast as I'd like to see us cut back on drum brakes, damn things are still on cars. Volkswagen just put out a new ID4 with drum brakes on a brand new EV for the reason that they don't rust up as bad and they work a little easier and they're cheaper. So I think a lot of it, like Mike said, it's not that we don't cover it, we cover it less.
I have to agree. I think you did a good job on hitting those things, Mike, because I've seen a lot of people that want to teach the old stuff, and something's got to give, and the old stuff is getting to the point you need to know some of the basics, but it is really history, So.
And like Mike said, in embedding it, we asked the faculty years ago and actually paid them to drop some just snippets. If you put an hour in a semester, say in a brakes class, talking a little bit about regen, in an engines class, talking about, Atkinson cycles, in a brakes class, whatever, the electric steering, for crying out loud, you drop those little snippets in there in a semester, it might cost you an hour. But by the time they get into your higher technology classes, whether it's hybrid EV or ADAS, they've heard something about it. It's not all new. And also the thing he mentioned, the siloed instruction. We all teach brakes, steering, suspension, engines very separately. At the end of the day, they all work together massively. And bringing that together at some point is getting the students to understand that, yeah, the transmission is going to affect the radio, which is going to affect the brakes, which is going to affect the butt massager. They're all together.
Great. Well, thanks, everyone. I know we've gone over a little bit, but Mike, this was really great. I'm seeing lots of comments in the chat about how much you have given folks a lot to think about. They're going to add induction motor principles to a basic electrical class, and adding different things and cutting different things. So the chat is full of lots of accolades and gratitude. So Mike, thank you so much. We are going to miss you when you retire, but we know that you're going to be coming back. So thanks so much. And everyone, we have another training on Friday afternoon at 1:30. James Lawrence, who has not spoken before as part of our training sessions, is going to treat us to an overview of a very innovative electrical class that he put together as a take-home project during the time of COVID. So he's using Arduino kits and basic programming and electrical boards to teach an electrical class. And this is something that high schools can think about doing. It's very low cost, very innovative, and was very successful. So he's going to share the details and give us a demonstration this Friday at 1:30. I'll send a follow-up email. And I'll also be sending out with that email some follow-up information on this training. This training, of course, as all the others, will be uploaded to the atleducation.org website. So Tesla can check it out too, Mike.
Well, I still have to send it to him. So I'm being watched constantly. But anyways, thank you, gentlemen, for participating. I got to tell you, I was more nervous about this than any class I've ever taught because I respect every one of you. And I was so scared of saying something that was stupid. So thank you for putting up with me.
Like, thank you. Appreciate it. Bye, everybody. See you all on Friday. Michael, thank you so much.